Alrighty, we're live. Hello, everybody. Welcome to our third week in a row of free response question review. Today, we'll be covering the 2017 free response question review. And although it does say Calculus AB on today's slide, I'm actually going to be touching on a few BC concepts if there are a decent chunk of BC people. It seems like in the last week, I think we had 2 or 3 BC kids, and I think that will be the line where I draw like 2 or 3 people is where I'll do BC stuff. If not, if there's just one, I'd refer you to, I see right now that one person has answered our poll who is in Calc BC. I would recommend you check out last week's free response question review, which is it covered the 2016 free response. We went over a Taylor polynomial approximation. We touched a little bit on Euler's method. So that is some good stuff. Alrighty, so I guess we'll get started in terms of the presentation. This is very short. I'm not going to be covering, the usual stuff in terms of like the new concepts on the exam, or the concepts that will be covered on the exam, since you've probably been here to know about that. But first of all, you should definitely go follow Fiveable social media. You'll see me on their TikTok. You'll see great memes on Twitter and Instagram, and we're uploading more YouTube content. Some of our old replays will be posted on the Fiveable YouTube channel. So definitely go check us out at Think Fiveable on all social media platforms. So in today's stream, we're going to start off with potentially some BC practice. I see that it's 7 AB and 1 BC. So it looks like there's only one AB person, or one BC per, oh, 2. Okay, then we'll still do some BC stuff. We have some AB practice and we'll have Q&A throughout. And Perla asked, are the sessions going to end after the exams, or will you guys go over non-exam topics? That is something that's in the works. I know that for like English language, we're thinking about maybe doing something where like, I don't know, we might have like debates, or we might do like TED Talks, something student run. We might also go over content that would have been on the exams like the College Board is doing. It just all depends. And we would love your feedback. Looks like TED Talks has some great support in the AP Calculus student community, which is pretty crazy. I'll probably bring it up during English language too. But I'm so glad to hear that y'all are positive about that. Okay, so yeah, what we're going to cover today with our BC stuff is we're going to start off with improper integrals, which is a concept that is BC only. But for those of you in Calculus AB, improper integrals does involve a U substitution, at least this question. So all of you in AB should still, participate on that question when we're doing our U substitution for our integral. And then we'll also be going over position, velocity, and acceleration. That was something that was requested last week. Then for AB, we'll be doing in and out functions. We'll be covering mins and maxes, a derivative application. We'll be going over the tangent line, separation of variables. We'll end with existence theorems. And if we have extra time, which I don't think we will, then we'll go over things like values of f from a f prime graph, f prime of a number, so the first derivative at some point, and composition of functions. But since we covered that last week, I didn't think we needed to repeat it. So these are mostly new things, although in and out functions will be happening every week in case they decide to add it back to the AP exam. So yeah, now I'm going to switch over to our new whiteboard, which is super exciting. So how this is going to work for those of you who are new here to, let's see if that works. You see my screen? Yeah. Okay, let me focus it. How this is going to work is that I'll technically be working out the questions, but throughout the question, I'll be kind of pausing y'all and kind of quizzing you on certain concepts that you need to know for the exam. So we're going to start off with improper integrals. Once again, this is a BC concept for our 2 BC friends here. So hopefully you've already looked over this. You know what it is. Basically, it's the integral from a number to infinity. I know it's kind of small text, so I'm going to rewrite it over here. It's the integral from 5. Oh, that's way too thick. From 5 to infinity of f of x dx. So, okay. Rashika said, I really like the interactive way you do FRQs. Thank you. I really appreciate it. And also, like, negative feedback is also perfectly welcome. If I'm doing something wrong, if I seem clueless, let me know, because, you know, you should tell me whenever I'm messing up, and also when I'm like doing good. Okay, so let's start off with this improper integral here. So as you can see at the top, it says, it gives us this identity. Can you go over the f values on an f prime graph? Akshita, yes, at the end. We were given this identity here, basically this long equation. It's asking us to evaluate this. Here, let me kind of draw. This equation right here, evaluate it from 5 to infinity, find that integral, or show that the integral diverges. So what we'd want to do here is we basically want to integrate. That's the first thing we want to do. That's what an improper integral is, except we kind of bring in this aspect of a limit, because as you can see, it's the integral from 5 to infinity. So what I like to do is I always use the letter n. I know some people use the letter b. It just all depends on what you've been taught. So I would write as the limit of n approaches infinity, we have the integral, whoops, there is no equal sign there. What am I doing? The integral from 5 to n is 3, I'm going to run out of space, but 3 over 2x squared minus 7x plus 5 equal to 2 over 2x minus 5 minus 1 over x minus 1. So basically, we're just finding the integral of this entire thing. And so then, don't forget your dx at the end. The stylus is like really trippy today. Then from there, we're just going to integrate. And so this is where all of my AB students, you can participate, and I encourage you to do so. So we have, basically we need to integrate from the integral from 5 to b, whoops, of 2 over 2x minus 5 minus the integral from, I like blanked over there, minus 1 over x minus 1. And so what we need to do from there is figure out this second part, 2 over 2x minus 5 minus 1 over x minus 1. So what's the first thing we'd have to do whenever we integrate? Whoops, that should be 5 to b. This should be 5 to b. So how do we integrate 2 over 2x minus 5? What's the first thing you would do whenever you try to integrate? A, B, B, C, you can both answer this. And it has to do with, yeah, but I would do something before making u equals 2x minus 5. I'd do something with this. Actually, in this case, you don't really have to move the 2 over. I would. But yeah, u equals 2x minus 5. And then what would du equal in that instance? Or how would we follow through with our u substitution? What would be next? Du over dx would equal what? Yep, 2 dx. So at that point, we would get du equals 2 dx, which is equal to, basically, dx is equal to 1/2 du. And so in that instance, we would take, that's why I would move the 2 over, because then you have 2, the integral of 1 over 2x minus 5, and then you would multiply by 1/2, and then from there, you would get, does anyone know what the integral of 1 over u is? This should be something you memorized. Lynn, yes. Great job, Akshita. Great job, Maria. Glad y'all are participating. So, yep, it's just ln, and in this case, because we have the 1/2 times the 2, that's times 1, we would just get ln of 2x minus 5. And again, apologies for the handwriting, but I think you can kind of decipher it. So then, same thing on this end. What would be the integral of 1 over x minus 1? Does anyone know? It involves a u substitution, but I'm not going to bother showing the work. And on the AP exam, I don't think you would have to, in that instance, show that, yeah, ln of x minus 1. And yeah, I would, right? Good job pointing that out, Akshita. I would put the absolute value. Yep, so ln of 2x minus 5 minus ln of x minus 1. Okay, and so for those of you who remember Algebra 2, what is our log identity where we subtract logs? What is that also? What can we do with that? Divide, yes. So then we could rewrite this, and I know you shouldn't erase work on the actual exam, but this whiteboard is limited, as you can see. So now that we have ln of 2x minus 5 minus ln of x minus 1, remember, by the way, that this is an integral at the end of the day. It's a definite integral, so you still have to put it from 5 to b, or 5 to n in this instance. So then I would rewrite this as, yeah, ln of 2x minus 5 all over x minus 1. And so then I would literally plug in 2x minus 2, or this should be 2n minus 5, excuse me, 2n minus 5, n minus 1. And then from there, am I missing something? As the limit of n is equal to infinity of ln of 2n minus 5 over n minus 1. And we also know that, let's look at the question again. We know that let f be the function defined by f of x equals 3 over 2x squared minus 7x plus 5. And then we need to use that identity and evaluate the limit from 5 to infinity of f of x dx. What's the next thing we would do for those of you in BC? Good job with the u substitutions, by the way. Does anyone know? Yeah, ln of 5 over 4. How did you get that, Akshita? Plugged in 5. Good job. And so then at the end of the day, you would get something along the lines of that minus ln of 5 over 4, because that's our integral. Remember, we sub in b, sub in 5 over 4. And so then what I would do is I would take this n minus 5, n minus 1, and I would think as n gets greater and greater and greater to infinity, what does it eventually equal? What would this turn out to be? So as n gets greater and greater and greater towards infinity, it would be ln of what? Not quite. It wouldn't equal 0, because think about it, as it becomes 100 minus, as 200 minus 5 over 100 minus 1. Yeah, it would equal 2. So then we would get 2, we'd get ln of 2, excuse me, minus ln of 5 over 4. And so then this is a non-calculator question. So then what would we do then with ln 2 minus ln 5 over 4? How can we simplify that? And great job with the 2, Perla. Divide 2 and 5/4, and what would we get as our end answer? What would we write as our final answer on the AP exam? 8 over 5. Great job, everybody. And once again, I'll get to AB very, very soon. Sorry, y'all. I think you can leave it as is. I would still write ln of 8 over 5 if I was taking the exam, because at least I think in this instance, simplifying would be good. Like, I think you should simplify if possible, but if not, I think ln 2 minus ln 5 over 4 would still get you credit. Good question, Perla. All right, let's move on to acceleration and volume. I don't want to take up more than 20 minutes, so I'm actually going to ask y'all, yeah. Perla, I don't know. I think typically it's the same in terms of consistency. I think from memory on the scoring guidelines, it said that you should write it as ln of 8 over 5, but I think 2 minus 5/4 would still work. This is a BC question. It says AB because it was on the AB exam, but this year it's not covered on AB. It's velocity, acceleration, and position. So I actually don't think I have time to do all 4 parts of this BC question. So for the 2 BC people still here, I was just curious, do y'all want, I'll show you the different options, I guess, and we'll do 2 of them. So we have when the particle is moving to the left, find all times t during which the 2 particles travel in the same direction. So that's part B. Part C here is find the acceleration of particle Q, and then it asks if the speed is increasing, decreasing, or neither. And our last one is the position at the time it changes direction. So which part would y'all want to do? I see someone says part B. Okay. No, position, velocity, acceleration is in Unit 8, and it was cut, Perla, so it is not on AB. So this stuff, y'all don't need to worry about. Like, you don't need to interact with me. Yeah. Wow, I see a lot of excitement. Yay. I love position, velocity, acceleration. It was my favorite part of AB and BC because I was in the AB class and took the BC test. Super convoluted. Okay, cool. I guess we'll do part B just for now. And maybe if time permits, we'll come back to A, C, and D because I just don't want to bore the AB people for too long. Okay. So, cool. So it says for 0 less than or equal t less than or equal 8, find all times t during which the two particles travel in the same direction. So remember when we read our BC or AB questions for calculus, you don't want to get things confused, right? So remember, they gave us a position equation for particle P, but they gave us a velocity equation for particle Q. And that is very, very important because a lot of kids will think, oh, those are both position equations, or oh, those are both velocity equations. They try and trick you like that. I expect them to do that on the real exam this year, especially because it's online. For BC people, I think they might come up with one of these kinds of questions, like a position, velocity, acceleration, and they'll try and put traps. That way you can't like use your notes and copy off of it. So let's look at how to approach this question. So what I think here, first of all, I like to write things out. And so I know that the velocity of VQ of t, that's written out as t squared minus 8t plus 15. Is there any way that we can simplify that? T squared minus 8t plus 15. And AB students, if you want to, like, I feel like some of you might have already learned position, velocity, acceleration. So if you want to chime in, you can. You don't have to. So how can we simplify this? T squared minus 8t plus 15. It becomes important whenever we do our sign charts. So that's why I'm asking if you know the zeros. This is a algebraic concept. So we take 15. I like to make t charts. Yeah, t minus 5 times t minus 3. Hello, Anyero. Nice to see you. Might have pronounced your name wrong. So we know that that's equal to t minus 5 times t minus 3. Great job, everybody. Glad to know your algebra is still doing great, especially during this quarantine. So we know that VQ of t is equal to 0 at t equals 3 and t equals 5. So then we look at we think when would they equal, when did the two particles travel in the same direction? So what I like to think is whenever they're traveling in the same direction, the velocity has to basically, both particles have to move in the same direction as long as the velocity is both increasing or decreasing. So if, for instance, if the velocity is positive for VP of t, and if the velocity of the particle and the velocity, if the velocity of particle P and particle Q are both increasing, then they're moving in the same direction. So then I would make a sign chart in this instance. So first I would draw VQ of t. And so VQ of t looks something like this. So we have 0, just because it's the intervals from 0 to 8. So we'd have 0, 8, 3, and 5. This is not to scale. And so this is VP of t. And then we have this is VQ of t. My apologies. This is VP of t now. And they give us that VP of t is at position x equals 5 at time t equals 0. So we know that in this instance, for P of t, one second. I'm silly. How do we find when the velocity of P of t is equal to 0? What would we have to do? If they only give us an xp of t, how do we find when the velocity is equal to 0? Well, what's the first thing we'd have to do? Yeah, we'd have to put the derivative equal to 0. And so whenever we put the derivative equal to 0, as we can see up here, it's ln of t squared minus 2t plus 10. So what rule do we need to use with derivatives in order to get a correct answer. Product rule? I'm giving you a wrong answer there. Quotient rule, that's one, right? What rule would we have to use to find the derivative of xp of t? Hint, hint, it's inside. And also this applies to AB students too, so feel free to chime in. Ln of t squared minus 2t plus 10. Chain rule, yes, we'd have to apply the chain rule. And so in this instance, let's apply the chain rule. So in order to do that, remember that first we would find the derivative of ln and then plug in the inside. And so it would be something like x prime p. Sorry again, my stylus and this board are just not working together today. X prime p of t is equal to 1 over t squared minus 2t plus 10 times, and then the derivative of the inside. And what's the derivative of the inside? Can anyone tell me? This is a BC concept, Daniela, because position, velocity, acceleration is only on BC, but I'm having some AB students answer chain rule, finding derivatives. 2t minus 2, great job, everybody. And so then from there, we have 2t minus 2 over t squared minus 2t plus 10. So then we can simplify that to 2t minus 1, right? 2 times t minus 1 all over t squared minus 2t plus 10. And we know that the top is where there will be zeros for rational functions. And so x prime of t equals 0 at where? At t equals what? It is unit 8, which is AB, but it's just not going to be tested this year, Quran. So if you were taking Calculus AB next year, this question would apply for the AP exam, but this year got cut because of distance learning. Do you think College Board is going to use really long and yeah? I think they will use really long, annoying rational functions. Akshita, good question. So where is the 0? When does this function equal 0? Can anyone answer? This thing I just circled. At t equals what? And this is x of p t. T equals 1. Great job. And so now all we have to do is find when they're both positive. And so then what I would do is I would, do our sign chart. So for VQ of t, I would plug in 1. So at 1, we know that 1 minus 5 is negative 4. 1 minus 3 is negative 2. So that's positive. Between 3 and 5, I'd pick 4. And in this case, 4 minus 5 is negative 1. 4 minus 3 is 1. That's a positive times a negative, so it's a negative. Between 5 and 8, that would be positive. And so then I look at 0, 1, and 8, and so I would plug in numbers. Remember that in this equation, the denominator is always going to be positive. So, and that's because of the t squared minus 2t. So let's say we take 0.5. So 0.5 minus 1 is negative 0.5 times 2 is negative 1. So that's a negative on top, positive on bottom. So that's negative. And then here from 1 to 8, it's going to be entirely positive. So then we know, what interval are the two particles traveling in the same direction? Does anyone know? There should be 2 intervals. That's a hint. 5, 8, and something else, right? And 1, 3. And remember, it's going to be different for each one. So I'm going to once again do some erasing here on the side. Whoops. And so from 1 to 3, is it going to be an open interval or a closed interval? Would it be 1 less than x less than 3, or would there be would it be included? And same for 5, 8. Oops, 5, x, 8. So in this instance, it would be open for 1 to 3 because between less than 1 and greater than 3, not included, it's not going to be increasing. It's not going to be going one direction or the other, right? Because at 1 and at 3, they're not traveling in the same direction. But at 8, it's going to continue going positive, positive, positive. So that's when it's closed. So it'd be 1 less than x less than 3, 5 less than x less than or equal to 8. All right, and so then it does say, like, this technically I don't think would be enough. I think you would also have to add a statement. I'm not going to type it out for time purposes, but I would say something along the lines of both particles move in the same direction for 1 less than t less than 3 and 5 less than t less than or equal to 8, since v p of t is equal to x prime p of t, and v q of t have the same sign on those intervals. So they both have a positive velocity, and thus they are traveling in the same direction. So 1 and 3 are open because at 1 and at 3, it's not traveling towards a positive right direction. At 1 and at 3, it's neither positive nor negative. But at 8, it's closed because past 8, at 7, 8, 9, 7, 7.99, 8, 8.01, those are all positive. Does that make sense? So at 1 here, right, it's kind of 0, right? It's not traveling in a negative direction. It's not traveling in a positive direction. So we can't include it in the interval. And same here at 3, right? At 3 and at 1, it's neither positive nor negative. But at 8, it's the end of the interval. So that's why we can have an equal sign. Yes, thank you, Karan, for answering. All right, AB students, it's now time for you to shine. We're going to start off with an in and out function, your best friend. So I know the text is a little small, so do y'all want me to post? I can probably post the FRQ links here. So we are on FRQ number 2. We're doing parts A and parts B. Actually, I think we've covered this last week. I think we covered parts A and B. Let me look at C and D, and maybe we'll do those instead. I guess I'll ask for an. I guess I'll ask y'all because, you know, once again, I think these FRQ reviews and kind of Q&As are powered by y'all, not by me. So it's more so what y'all want to practice. So would you rather look at how many? So I guess the first part A is how many pounds of bananas are removed. So that's a pure kind of integral question. Because you're taking a rate and finding the number that are removed, and then part B is a derivative. I see part D in the chat. Would y'all rather do A and B or C and D? I think we'll do C and D because I think we've gone over these parts A and B multiple times already. Okay, C and D it is. And for those of you who want to look at how to do A and B, I would recommend you check out my past FRQ reviews. I've already done 2 of them, and you can check out our in and out functions. All right, we got consensus. Great. I'm glad that y'all want to do C and D. So let's look at parts C and parts D. I just don't want to go over an hour and 15 minutes again and keep y'all here unnecessarily. I want to be respectful of your time. Okay, so let's look at what it's asking. So it's asking for part C, is the number of pounds of bananas on the display table increasing or decreasing? So are we dealing with the rate functions? Are we dealing with the derivative of the rate functions? Are we dealing with the integral of the rate functions? What are we dealing with? If it's asking if the number of pounds on the banana display are increasing or decreasing. So okay, Akshita, you said second derivative. We'd want to be careful here. Yeah, it's just the derivative. It's just g of 5 minus f of 5. Or in this instance, I think I would do, yeah, g of 5 minus f of 5. And so if any of y'all have a calculator in front of you, Desmos, TI-83s, T-Inspires, I want y'all to put that in your calculator and tell me what you get. G of 5 and f of 5. And what do you get g of 5 minus f of 5? What's the specific answer you get? So I see someone answered negative 2.263. Okay. See if everyone else gets that answer. I want to just make sure. I'm pretty sure your answer is right from what I remember. So I did this practice question a long time ago. The cap fell off here. I'm trying to look for it. There it is. Yeah, negative 2.263. Great. And so then that's less than 0. And so then what would our interpretation sentence be? Well, we can't just say it's less than 0. What else would we have to write? So I want y'all to kind of answer in the chat what you would put as your kind of like sentence answer. Because calculus does have a little bit of writing. Okay. Because g of 5 is greater than f of 5, number of pounds is decreasing because the overall rate of change is negative. Rashika, that's good. I would add, instead of, I can't talk apparently. I want to be as specific as possible. So I would say something like, since g of 5 minus f of 5 is less than 0 at t equals 5, the pounds of bananas on the display table are decreasing. So rather than saying something like the rate, Daniela, or the overall rate of change, I think you should specify the g of 5 minus f of 5. It also links your work into your answer. But also, if you've already done this FRQ, or if you've done questions similar to this and your teacher told you to write it a certain way, do what you're comfortable with, because that's what you want to do on the AP exam. At 5 pounds, the number of pounds of bananas on the display table is decreasing. It's decreasing because more pounds are being removed instead of added. Yeah. I think you just want to make sure you're justifying based on the first derivative, and the best way to do that is g of 5 minus f of 5 is less than 0. Okay, let's do part D now. So the first thing I would always check for in and out functions, and what they always manage to get people on, is initial conditions. So what is the initial condition here? When the grocery store opens, how many pounds of bananas are there? I sound literally crazy. I'm talking about bananas. Yeah, 50 pounds of bananas on the display table. Great job, everybody. So because we know that there's 50 pounds at the beginning, let's look at part D here. How many pounds of bananas are on the display table at time t equals 8? So what do we always want to start off these kinds of questions with? We want to start off with what? Hint, it's what I just mentioned. Yeah, 50. It's our initial condition. So 50 plus, and then would we be using the integral of these rate functions, a derivative of these functions? What would we be using? The integral. Great job. Guys, y'all are like smarter than me. I'm so proud of you. So 1 second. Okay, so 50 plus the integral from what to what? Okay, I see 0 to x. Let's be a little bit more specific here. Okay, what is it? It's asking how many pounds of bananas are on the display table at time t equals 8, right? And so some of y'all are saying 0 to 8, but let's look at g of t, right? G of t is the amount of bananas that are coming in, if I'm correct, right? Yeah. G of t is measured in pounds per hour. Store bananas add, yeah. So it's 3 of 8 for g of t. Quran got it perfectly there. It's 3 of 8 for g of t and 0 to 8 for f of t. Because remember, they're not adding any bananas until hour 3. So it would look something like 3 of 8 of g of t minus 0 to 8 of f of t. So here, and sorry, you should be putting dt at the end. dt. Yeah, so it's very, very tricky. Are there any instances where you wouldn't use the initial condition? I don't think so, not off the top of my head, unless you, like, if you were finding, like, I guess this is kind of a silly question, but for me at least, you're not asking a silly question. It's a silly answer from me. I think you would use the initial condition almost in every instance, unless it was asking how many were removed or how many were added. Does that make sense? Yeah. As Quran said, if it just asked for change. If it said how many bananas were removed from at this time or this time. Yeah. Good question. Perfectly, like, understandable. When they ask for an overall rate or how many pounds are at this time, you definitely need to include the initial condition. So can anyone put this in their calculator and tell me what they get as their answer? 50 plus the integral from 3 of 8 of g of t dt minus the integral from 0 to 8 f of t dt equals what? Haha, quarantine. I get it. You know, you and Kung Flu Panda, y'all have the best names. I'm just saying. I think Kung Flu is a stats person, though, but I think I saw him in one of my calculus strains. 23.347. Yep, that is the correct answer. So what would y'all's interpretation be? What would your answer be? Because just writing 23.3 whatever probably wouldn't get you credit. Oh, hello. Hello, Mr. Kung Flu. Nice to meet you. Best names. So what would you write? You wouldn't just write 23.347 for this answer. You would write something else. By the way, props to you for taking calculus and statistics in the same year. That's insane. Because I remember I was watching a stats cram stream, and you're making good jokes. Yeah, 23.347 pounds of bananas are on the display table at time t equals 8. So remember, you want to include context because it's always helpful. Okay, let's look at parts C and D of number 3, because I remember someone last week requested mins and maxes. And in this case, we're looking at the absolute minimum value. Where does College Board come up with these topics? Akshita, usually they look at a bunch of different syllabi for Calculus 1 at the college level, and they just teach, they put everything in College Calculus 1 in Calc AB, and then they put College Calc 1 and some of Calc 2 in BC. Good question. Oh, bananas, you're funny. Who knows? Maybe they just pick a fruit or vegetable. So let's look at 3C here. It's talking about the absolute minimum value of f, right? So what's the first thing we'd want to do in terms of finding the absolute minimum of that closed interval? Or I guess a better question, is when would we see an absolute minimum? And so the answer is, what Akshita said, which is finding where the first derivative, f prime of x, is equal to 0. And Quarantine here says, would you say going from f to f prime and finding mins and maxes and increasing or decreasing is a very important topic? Probably something you should know, but it's not incredibly difficult, at least in my opinion. As long as you keep doing the practice and working hard. Like, I think compared to like related rates and separation of variables, which is the next thing we'll be touching on, that stuff is a lot more difficult. And have fun, guys. Find where the derivative changes sign. Okay, so those are some good answers. So I would say that the absolute minimum occurs at either an endpoint or where f prime of x is equal to 0. So then I would write something like, when does the first derivative equal 0? And so can anyone tell me from this beautiful graph, when does the first derivative equal 0? And that is to scale, And also remember that it has to be within the interval. And so someone said x at -2, but that's not a min, x equals 2. I would still consider x equals -2 just in case. You should always look at when the first derivative is equal to 0, even though it might not be a minimum, just College Board being stingy. So then I would make a lovely t-chart, x, f of x, and so then we have -6, -2, 2, and 5. And don't forget, you need to consider the endpoints. Do I need to do additional justification? Well, you need a sentence after the chart. So you would have to say something like, the absolute minimum value is f of something. Does that make sense? Okay, so then, let's look specifically. I think I might have cut out important information for you to answer this question, and that is my fault. So let me open up the FRQs and see what I missed, because I feel like you can probably solve some of these in terms of finding slope at a point. Let me make sure. Okay, it does tell you that f of -2 is equal to 7. So that is important. It does say that f of -2 is equal to 7. That's an initial condition given. My apologies on cutting that out. And then it says that, so then from there on out, what else could we do? Oh, and part A and part B just makes you calculate f of -6 and f of 5. So can anyone tell me what f of -6 and f of 5 are, or how would we try and solve that? So we would integrate from -2 to x, okay? So what I would do to find f of -6 and to find f of 5 is I would first start off with our initial condition, which is f of -2. And then I would add that to the integral from -6 or sorry, -2 to -6 of f prime of x dx. And then that would flip and become 7 minus the antiderivative, or the integral of -6 to -2 of f prime of x dx, which is equal to, well, actually, I'll have y'all work that out. So, okay, you got 7 minus 2 pi. Which point was that for? 7 minus 2 pi. Is that for -6, 2, or 5? 2? Yeah, that's right. Okay, I was like, what? 7 minus 2 pi. Okay. And so then I want y'all on your own paper to work out f of -6 and f of 5 and tell me what you end up getting. -2 to 5. And by the way, if you need more practice with these kinds of questions, next week, April 27th at 9 p.m. Eastern, one of our wonderful math teachers, I think it's Bob Amar, will be covering specifically these kinds of graph derivative questions. So if you need more practice, I highly encourage you go there. You got 2, Akshita. Yep, and that is the value for f of... No, wait, yeah, it's not 2. I was like, let me think here. F of -6 is equal to 3. And so that's because you get 7 minus 4. And that's because you're subtracting the derivative from -6 to, subtracting the integral from -6 to -2, which if you draw that little triangle thing, it's going to get you 4, if I'm correct. 7 minus 4. Yeah, Akshita, if you got f of -6 equals 2, that's not correct. It's also not f of 5, because f of -2, I think I'm going crazy a little bit. F of -6 is equal to f of -2 minus the integral from -6 to -2 of f prime of x. And so this is +4, this area, because it's 1, 2, 3, 4 times 2. 4 times 2 is 8. 8 divided by 2 is 4. 7 minus 4 is 3. Yeah. Oh, 7 minus 2 pi. That is the correct answer for x equals 2. Can anyone tell me what they got for x equals 5? Have you gotten that far yet? And here, if you need a better picture of the graph, I kind of already gave you part of the answer there. The integral from -6 to -2 is 4. Yeah, 10 minus 2 pi. So then what would our minimum be? Which answer is the smallest? 3, 7, 7 minus 2 pi, or 10 minus 2 pi? Akshita, the way you would get that is f of -2 is equal to 7. And then the integral, I'm so sorry, from -2 to 5, from -2 to 2 right here, that part is equal to from here under the curve, that's -2 pi under the circle. And then here it's +3. And so then 7 minus 2 pi plus 3, that would get you 10 minus 2 pi. And the 7 we get from f of -2. So f of -2, it's basically f of -2 plus the integral from -2 to +2, and then the integral from +2 to 5. And so the integral, first we have f of -2, which is 7. Then we subtract 2 pi, which is this part. Then we add 3, which is this part. So that gets you 10 minus 2 pi. So what's our absolute minimum here for part C? Yeah, 7 minus 2 pi. And so then our interpretation would look something along the lines of the absolute minimum value is f of 2 equals 7 minus 2 pi. So now I'm going to proceed to erase everything. And now we're going to do part D. So for each of f, the first derivative of sorry, the second derivative of -5 and the second derivative of 3. Find the value or explain why it does not exist. So let's start on this question. So let's look at each value individually on its own. So let's look at the second derivative of -5. And so I'm sorry, I think I colored it out there, but -5 is like right, it's on that curve. It's on this line here. So what would the, can we do the second derivative of -5? And if so, what would it be? Yep, it's -1/2, and I would show some work for that. So I would do something like 2 change in y over change in x. So 2 minus 0 over -6 minus -2. And so then we get -1/2. And then can we do the second derivative of 3? So how do we, nope, it's a sharp point, but how would we write that out on the actual thing? On the actual exam, what would we say? Excuse me. Seems like I can't speak English. Not differentiable. Yep. And how do we prove that something isn't differentiable? Yeah, when the limit from the left is not equal to the limit from the right. And so this is a tough question. So first I would write that the limit as x approaches 3 from the left of, and so what, does anyone remember the definition of a derivative? This is something that I learned pretty early on in the school year. Yeah, so the way you find the second derivative of -5, so in this case, we're looking at instantaneous rate of change. All right, we're back with part D. Sorry again for the technical difficulties. But basically, whenever we look at the second derivative of -5 and the second derivative of 3, we can see that for the second derivative of -5, the slope to the left, so the slope as f approaches as f prime approaches -5 from the left and from the right, it's the exact same slope at -1/2. But when we look at the second derivative of 3, we see that from the left, the slope is increasing at a rate of +2/1, whereas the slope as we approach f prime of 3 from the right, we can see that it is a -1 slope. So we can see that this slope right here and this slope right here are different. Thus, the second derivative of 3 is not differentiable, and it's therefore, it doesn't exist. And so the way we write that out is as I did here. So you basically have to write out the limit as x approaches 3 from the left with the definition of derivative here, which is f prime of x minus f prime of 3 all over x minus 3. We can see that from the left, the slope is 2, +2, whereas the slope from the right is -1. And thus, since the limits do not equal each other, the second derivative of 3 does not exist. So let's move on to the next question. So what I planned next was separation of variables, in addition to covering equations for the line, equation for the tangent line and things like that. We can still do that. It's just you'll have to follow along on your own paper. And I'm also going to do a few callbacks, which will be a little awkward since I won't be able to respond. I won't be able to stuff. So let's look at question 4 here. First, we're going to look at A. So it tells us that we need to write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So the first thing we need to do is we need to write an equation in the form of y equals mx plus b with an m and a b. And we know that h of 0 is equal to 91. So we already have our b. So now to find our x, to find our slope or to find our m, what we would need to do is find the derivative, because once again, derivative is slope. So h prime of 0 in this instance would just be the derivative that's given, -1/4 of h minus 27. So -1/4 times 91 minus 27. And so that gives us -16. So for part A, then we just put it all together. We know that y equals m, which is -16 t plus 91. And remember, we use t because we're finding it in terms of time. So then we would have to estimate 3. So we do y equals negative 16 with 3 plugged in plus 91. And we ultimately get 43 degrees Celsius. That's our estimate. So now let's work on part B. So it says to use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. So let's use the second derivative. So the first thing we need to do is find the second derivative. And while that seems a little bit difficult, it's just a simple chain rule. So let's erase all of this stuff. And so the first thing we need to do when finding our second derivative is the chain rule, as I just said. And so that would look something like d squared h dt squared. That would equal something along the lines of negative 1/4. Because remember, the derivative of negative 1/4 h minus 27 is negative 1/4. So it's just negative 1/4 times, negative 1/4 of dh dt. So that would be our second derivative. And then ultimately, whenever we multiply, we get 1/16 dh dt, and we can rewrite that as 1/16 h minus 27. So then we would see that h is greater than 27 when t is greater than 0, because that's how the second derivative functions. We know that d squared h over dt squared equals 1/16 of h minus 27 greater than 0 for t greater than 0. So then we know that overall, the graph of h is concave up. It's concave up for t greater than 0 because the second derivative is greater than 0. And thus, because the graph of h is concave up, the answer is an underestimate. And so while that doesn't seem like it makes a lot of sense, you just have to think if the first derivative looks like a classic y equals mx plus b, right? Or sorry, the first derivative is negative 1/4 times h minus 27. The second derivative is 1/16 h minus 27. It's fundamentally going to always be above the x-axis, and thus the estimation that we gave in part A is an underestimate. Now let's go to part C. And this is our second to last question. So this one is a fun separation of variables. So it gives us dg over dt equals negative g minus 27 to the 2/3 power, and that's right over here. And we know that's where g of t is measured in degrees Celsius and g of 0 equals 91. Once again, that initial condition. So it says to find the initial temperature of the potato at time t equals 3. So it's basically making us find the actual thing. So the way we do that, and the way I would handle this question, is that basically we are looking for the internal temperature, which in this instance is G. So how would we given a T, find G of T? And so I would write this immediately, something along the lines of, first I would separate our variables. So dg over dt is equal to negative g minus 27 to the 2/3 power. And so we know that we need to get the t by itself on that side, and we need to get the t basically on its own and the g's all together. So then I would basically swap these, and you'd get dg over g minus 27 to the 2/3. The negative would stay on that side because all we'd be doing is dividing by g minus 27 and then multiplying by 1 over dt, or multiplying by dt, excuse me. We get negative dt. So we get dg over g minus 27 to the 2/3 equals negative dt. And from there, we would need to separate our variables. And so then we would integrate both sides, and you would get something along the lines of 3 times g minus 27 to the 1/3. And we would get that basically because g minus 27 to the 2/3 would be, well, g minus 27 would be our u, and then eventually we would get, it would be g minus 27 to the negative 2/3. And so we use our regular integration functions, and we get 3 times g minus 27 to the 1/3. And so that equals negative t plus what? Whenever we integrate an indefinite integral, remember, we always need to put the constant of integration, c. And that's really, really important. So then they give us our initial. So let's recap. So from here right now, all we've done is we separated variables to get g sort of by itself. And now we need to find what the constant of integration is. So what would we use now that we found the integral of dg dt, which is just g of t? How do we find the c? And the answer is to use 0, 91, the initial condition. So once we plug in 0 and 91, what do y'all get? C equals what? Do it on your own paper. So plug in 91 for G and plug in 0 for T. All right, the answer, C equals 12. So then we have 3 times G minus 27 to the 1/3 is equal to 12 minus T. And we can rewrite that as G of T is equal to 27 plus 12 minus t over 3 cubed. And you would basically just, in this equation, get g by itself. So you would divide by 3, then you would cube both sides, and then add 27. And so now that we have that, and remember to include any domain restrictions. In this case, it would be t is less than 10, so 4, 0 is less than t, 0 less than or equal to t less than or equal to 10. And then you would plug in t equals 3, and what degrees Celsius would you get as your final answer? So plug in plug in 3, t equals 3 into 27 plus 12 minus t divided by 3 cubed, and you would get 54 degrees Celsius. And if this is confusing, that's okay. Hopefully next week, my FRQ review will not have an internet interruption, and we'll go over another separation of variables question if this is too confusing. All right, and finally, we're going to end with an an existence theorem. So here they give us this graph and this table, and they tell us that f is f of x, g is differentiable, and it gives us the values of g in the table, and then it says h is that graph. So what it's asking here, it's dealing with the table. It says, is there a number c in the closed interval from -5 to -3 such that g prime of c is equal to -4? And so this, what would we be doing to justify? We'd have to use one of our theorems, right? And if you need help with existence theorems or justifications, I highly encourage you watch live or watch the replay of our April 20th at 9 p.m. Eastern stream for justifying and explaining your answers, which will also be taught by me on a live stream. But in this case, we would be using the mean value theorem because that's the basic function where it's g prime of c is basically equal to g of b minus g of a all over b minus a. And so in this instance, it's basically saying, is there a number c in the closed interval -5 to -3 such that g prime of c is equal to -4? So remember, there are a few conditions that need to be met in order for us to prove the mean value theorem to be true in this instance. And those two conditions, does anyone remember? Those two conditions, the first is that g needs to be differentiable, which is given in the equation. And you do have to write out that g is differentiable. So g is, I'm just going to shorten it, but on the real thing, you'd want to write it out. And we'd also say that g is continuous on the closed interval, from -5 to -3. And so then we would plug in g of -3 minus g of -5 is all over -3 minus -5. I'm just using the slope function from above, and that's equal to -4. And so then we would we would justify by saying something along the lines. I'll just write it out via text. By NVT, and you can write mean value theorem on the real thing. I don't think it matters. There is at least one value C from -5. Whoa, text is getting trippy. -5 less than C less than -3 such that G prime of C is equal to -4. There we go. And so that's what I would write after showing that work. So the first thing is to prove that G prime of C, G is differentiable and continuous. Then we plug it into our master function here, this, this G prime, basically change in Y over change in X from the interval that's given. We solve it, we find -4, and then we justify. And that's it. Thank you so much for showing up to the first 50 minutes and even watching through this extra extension replay video. I really appreciate y'all's support. Hopefully this won't happen again. But once again, really appreciate you spending the time with me to learn calculus, practice calculus, work on your theorems, work on in and out questions. And yeah, I'll be seeing you in the coming weeks before the AP exam.